Starting. Okay, amplitude and period of sine and cosine. So we'll start there. That's a 2. Y equals 2 sine x. Any number in front denotes the amplitude. Okay. In music terms, that means it's too loud, you're too old, right? So it's volume. What does this graph look like? Okay, the period is still 2 pi. The only thing that changes is the height of the graph. So generally it's -1 to 1. Now we just stretch it -2 to 2 because it's 2. Like that. Okay. So we just stretched it a touch and made it louder. Very easy, very straightforward. You get to pick on your project that number. I don't care what it is. Now you'd be kind of mean if it's like 10 million, but you can leave it 1 if you want. Okay. So take your pick. Amplitude is very easy.
That'd be a big graph.
Yep. What happens if I make it negative?
It goes down.
Yep.
It gets flatter and flatter.
It just flips it over the x-axis like we talked about. It's just like parent function. You have the parent function, you're just manipulating it like we've been doing for a couple months now. All right. Let's talk about period. For music terms, period is 1 over frequency, and I will explain that. Okay, a sound wave moves, right? Moves past your eardrum, makes it vibrate. Okay, the frequency is the number of periods or number of cycles per second. Okay. So let's say a middle C, very commonly used. Why did I do that again? 262 hertz. Okay. So 262 of these right here are passing your eardrum every second with a middle C. Okay. 262 of them. Okay, because the speed of sound is pretty high. Yeah, 1 full cycle, you have 262 of those passing your eardrum every second on a middle C.
At -2 or whatever?
No, that's the amplitude. I'm just talking frequency. So the period, I'll talk about period here in a sec, but our audible range for humans is anywhere from 20 hertz. So 20 cycles per second would be really, really bumping and thumping, right? And up to 20,000 hertz. Okay. really high range. I probably can't hear that anymore, honestly. Too much loud music. Okay. So that's kind of what frequency is. Number of cycles that pass your eardrum per second. Okay. So to put that into a function, you have to know the value of K. The period is 2 pi over K. Yeah, you commented about my limited dependence. Yeah. I didn't tell you guys what happened second hour yesterday. I told the story about this because they asked it was popping into the camera. About 5 minutes later in the video, I get an email from somebody that's watching the video live. Sorry to hear about your dog. I hope he's okay. That's pretty funny. So people are actually participating in our classroom. It could be as we speak. All right. So there's a little process here. Let's graph. Give me a value for K that's nice. Let's try something fun. Of course, I just totally ignored you after I asked for your opinion. Okay, so K is 1/2, correct?
Yep.
So what's the period? Which is, nope. Remember copy, dot, flip. It's like 2 pi times 2 is what it is.
Is that y2?
What?
Oh, 1/2.
1/2.
Okay.
Yeah. Now, if I want to graph that, what's my amplitude?
It's 1.
1. Okay. Now my period is 4 pi. So when I draw it, I just draw it repeating at 4 pi instead of 2 pi. So that is 1/2 theta, sine 1/2 theta. So it stretches the period from 2 pi to 4 pi. It's like taking a spring and stretching it out. Some of you said 7 as K. That would compress it, and the period would be 2 pi over 7, or 2/7 of pi. It would be really itty bitty. Okay. With fractions there, it stretches it out to make it nice and long. Okay. Lower notes have a longer sound wave. Higher notes compresses it. Okay. Are you okay with that? Figuring out the period and graphing. Yeah? No? Okay. Okay. You have to write a function for your project. So let's write a cosine function with amplitude -6 and period 3 pi.
So when we do this for a project, are we gonna pick the number?
You get to pick the amplitude, but the period is, the value of K is determined by the frequency of the notes you picked from your music piece. That's my next example. I'm going to show that to you.
Okay.
Yep. All right, so we need two numbers, amplitude here, right? So -6. But how do I figure out the K value? How do I use that to find K? That's the question at hand. The period is 2 pi over K, right? It is also 3 pi. Solve for K.
2/3.
Yep.
Oh my gosh, I'm dead.
Well, cherish it. Divide by 3 pi. So the pi's cancel, you get 2/3 equals K, and we can go ahead and plug it in. So -6 cosine 2/3 x.
I have a question.
Yep.
I'm confused why we did that.
Why I calculated K?
Yeah.
When you write your function, the value in front of the x or the theta is what you need to write the function, the K value. That's not directly linked to the frequency or the period. Okay, you have to use this formula to find K. So the period is 2 pi over K. Now if I have the period, 3 pi, I have to set that equal to 2 pi over K in order to solve for that number to put it in the function. Clear? As mud? Or as my daily drink? Water? Do you understand? Okay. You got to give me some feedback here. I can't operate on nothing. Couple a day. Okay, let's pick. Okay, let's pick a note. Middle D. Some of you might have a D in your chords, right, that you pull out. So I'm going to Wolfram Alpha, and it tells me it operates at 294 hertz. Give me an amplitude.
4.
Okay, 4 it is. So I'm going to write and graph a function for that note. Remember, period's 1 over frequency, right? So if we want to find the value of K for our function, there's your formula, I would say. Period's 1 over frequency, so 2 pi over K equals 1 over 294. Go ahead and solve for K. cross multiply. It's 294 times 2. 588. Nope, I would just leave it, honestly. So what's my function? We're always going to use sine here. For music. Y equals 4 sine 588 pi. And I'm going to use t for time. Just because I like to use t for time.
So
That's your written function.
what did you get that function? We made it up.
Yeah, I just pulled it out of thin air. Okay, 4 is your amplitude, right?
Yeah.
We use sine for sound waves. The 588 pi comes from calculating k. Because it's k right there. So you use the frequency and the period formula to calculate k.
Yeah.
Well, you can put x, you can put
But why do you
theta.
have to?
I put t because it's a general mathematical denotation for time. It's a variable.
So like
The music operates in time, right?
our equation for our project is gonna, the simple one is y equals sine k theta.
K theta, kx, kt, whatever.
Oh,
All right, graph this. Okay, here's, if you're graphing these by hand, you have to zoom in really far. Because the period of this function is 1 over 294. Okay, so we're doing 1 second, or 1 cycle of this function. Well, 294 of them pass per second. So 1 over 294 is going to be our period. What decimal is that? Anybody with a calculator?
0.03401.
Yep. Our amplitude is 4. Now this is where it's kind of neat. Half of that is 0.0017. And you have your curve, your wave. It's really not that hard.
that's weird.
Okay,
Other calculators.
okay, so that's just a basic note. And note that this is in seconds. Okay, so one of those wave periods passes by every 0.0034 seconds for a middle t. Pretty quick. If you're graphing a chord and you want to move to advanced, this is what chords look like. Because you have 3 different notes playing with each other, right?
Yeah.
So it's going to manipulate that sound wave to look like this. This is an A.
We do this right here 6 times.
Yeah, for each note. Now what I suggest
What are the harder chords that would be with advanced chords, like A minor and stuff?
is graph y equals 4 sine 588 times 3.14 x. This is the Wolfram alpha method. And you copy and paste that into your document. You're going to turn in as a written report. Okay, so here's 2 cycles. Here's 1, 2, 3, 4, 8 cycles. Okay, so they give you some options. You can copy, paste these, or save them and insert them into Google Docs. All right. I suggest the computer way since I'm looking for a written report electronic document. So you know how to do it both ways.
Like when we turn everything in, we're gonna turn in our report, and then we'll turn in like all the work to show that we like know how to do this, right? Or just a written report.
Your written report is whatever's in this rubric.
You don't have to turn it in.
So you have to have your chords, your notes that are broken down from your chords, and then you have to have your functions for each of those, and your graphs for each of those. It's very easy for me to verify that you did the work right. Because it will be correct. Yeah. No, you don't. If you want to show your work, you can.
Oh, because but like, why wouldn't you want to see our graphs? Why would you let us do it on the computer? But we have to figure out the function.
You have to write the function before you can get the graph. So, yeah. Okay. Any questions on the musical part of this? Okay. Here's your practice for this. Good. That's kind of how these projects generally work. 2. Well, the second number is a 3, so can you be logically inclined and deduce what number that should be? I don't know. I don't know. I don't use logic. On that note, we'll sign off from the internet.